In the last lesson, we developed the concept of wave motion. In this lesson, we will develop the concept of harmonic waves. Now, what is a harmonic wave? A harmonic wave is the propagation of wave caused by the simple harmonic vibrations of the particles of the medium. A wave generated by the simple harmonic vibrations of the particles of a medium is called a harmonic wave. That means if you want to write the equation of a harmonic wave, it will be the same as the equation of the simple harmonic vibrations of the particles. Alright, tell me, what is the equation for the displacement of a simple harmonic motion? Do you recall that equation? The displacement of a simple harmonic motion. We discussed the displacement, then we obtained equations for velocity and acceleration. Alright, tell me, what is the equation for the displacement of a simple harmonic motion? You need to recall these simple ideas. Now, at t equal to 0, if the particle is at the equilibrium position. At t equal to 0, if the particle is at the equilibrium position, then the displacement at any given time is given by y equal to a sine omega t. We found at t equal to 0, if the particle is at the uppermost extreme, the phase angle is pi by 2, then the displacement is a cosine function. So the displacement here is y equal to a sine omega t, assuming that at t equal to 0, the particle is at the equilibrium position. Alright. Now, since a harmonic wave is formed by the varying displacements of the vibrating particles, the equation for a harmonic wave is the same as the equation of displacement of a simple harmonic motion. So what is the equation of a harmonic wave? It is the same as the equation for the displacement of a simple harmonic motion, namely y equal to a sine omega t. And we can actually write it in many different forms. For example, omega is called the angular frequency, is written as omega equal to 2 pi f. You know that. I told you some time ago that we're going to use it profusely as we go on. Omega equal to 2 pi f also is 2 pi divided by the period. So you must be able to express omega in terms of the frequency and also in terms of the period. So I can now write the equation for a harmonic wave as a sine 2 pi over t multiplied by t. Don't confuse here. The big T is the period and the small t is the time. In other words, you have y expressed as a function of time. 2 pi over the period is a constant. So the equation for a harmonic wave is y equal to a sine 2 pi over the period multiplied by time, which is the same as, 2 pi divided by the period is the same as 2 pi times f. We will be using it continuously. A sine 2 pi ft. A is the amplitude of the wave. Well, amplitude of the particle is the same as the amplitude of the wave. For example, if I draw a transverse wave. Now, what does actually this means? It means a particle here is now on the crest, and at this position the particle is on the trough. So the face of this particle, this particle is now on a crest, and a particle at this position is on a trough. Now, this is the amplitude of vibration of the particle, the maximum displacement, and therefore that is the amplitude of the wave. A is the amplitude of the wave. F is the frequency of the wave. In other words, F is the number of vibrations of the particle. Now, remember, when the particle completes, I want you to understand this very well. When the particle completes one vibration, the energy advances by a distance of one wavelength. In other words, we have produced one full wave. If the particle vibrates 2 times, it produces 2 full waves. So the frequency of the wave is the number of waves produced per second. The number of vibrations of the particles per second is the same as the number of waves produced per second. Now, A is the amplitude and F is the frequency. The displacement y can also be written as a function of x. What does x represent? X represents the distance along which the wave advances. So you can also represent this y as a function of x. As x increases, how does the displacement change? Let's do that. You know that F equal to V over lambda. Now, where does this come from? From the wave equation. What is the wave equation? V equal to F lambda. So we have F equal to V over lambda. What happens if I replace this F in the equation by V over lambda? I get Y equal to A sine 2 pi, in place of F I have V over lambda multiplied by time. Alright, now I'm going to write this as, I want you to watch it carefully. It is written now as Y equal to A sine 2 pi divided by lambda times Vt. Vt. What does Vt stands for? V is the speed, T is the time, V times T is the distance traveled, which is, it is traveling along the x direction. Therefore, V times T will be x, the distance traveled. Is that right? So that is Y equal to A sine kx. So you can now see you have the equation of a harmonic wave as a function of x. This is the equation of the harmonic wave as a function of time. Y equal to A sine 2 pi ft, or Y equal to A sine omega t. You see that? 2 pi f or 2 pi over t, they are both omega. So Y equal to A sine omega t, the equation of the harmonic wave as a function of time. Y equal to A sine kx, the equation of a harmonic wave as a function of x. Now, this quantity 2 pi by lambda is what we call this k. So what does the k stand for? 2 pi by lambda, and it's called the wave number. Now, what does the wave number stands for? Look at this, 2 pi divided by lambda. Lambda is the wavelength. So in other words, in one period or in an interval of 2 pi, how many waves are there? The number of waves in an interval of 2 pi is called the wave number. This quantity 2 pi by lambda is that wave number. I want you to be clear about this k. Do not confuse it with k for the spring constant. Remember, in the past couple of lessons we have been using a k for spring constant, which is the same as m equal to, we express that in terms of omega and k. Is that right? That is not the same k here. This k is 2 pi divided by lambda, and it's called the wave number. So please don't confuse with the k. Y equal to a sine kx is the equation of a harmonic wave. Now, a wave is either advancing to the right or advancing to the left. How do we make that possible in the equation? To describe a wave advancing to the right, we replace this x by x minus vt, where v is the wave speed. That means the equation of a wave that is advancing to the right will be, you replace this x by x minus vt. Y equal to a sine k times x minus vt. You see that? X is replaced by x minus vt. This is now the equation of a wave that is advancing to the right. In that case, what will be the equation of a wave that is advancing to the left? This minus sign will be replaced by the positive sign. That's all the difference. And now, if I replace this k by 2 pi by lambda, it will become y equal to a sine 2 pi by lambda times x minus vt. We can distribute that 2 pi by lambda. What does it become? It will be 2 pi by lambda times x minus 2 pi by lambda times vt. Alright? Can you tell me, what does v over lambda represent? I have colored that red. That means there's a significance. What does v over lambda represent? Anybody tell me? If you know your wave equation, what is the wave equation? The wave equation is v equal to f lambda. So, if v equal to f lambda, what is v over lambda? V over lambda will be f. So, I'm going to replace this v over lambda by f and this 2 pi by lambda by what? What is 2 pi by lambda equal to? Equal to k. So, the equation now is y equal to a sine kx minus 2 pi ft. I'll replace 2 pi by lambda by k, and v by lambda is f, so that will be 2 pi ft. Can you now tell me what does 2 pi f equal to? Can I replace this quantity by another quantity? That will be y equal to a sine kx minus omega t. 2 pi f is omega. So what does this equation now represent? This equation is the equation of a harmonic wave that is advancing to the right. Similarly, the equation of a wave that is advancing to the left can be written as, alright, can you modify this equation to represent a wave that is advancing to the left? Yes, that is simple. That will be y equal to a sine k times x plus vt. See that? And when you write it in this form, it will become y equal to a sine kx plus omega t. Y equal to a sine kx plus omega t. These two are the same equations. So you must be familiar with these equations. Alright, let's take a look at well, you have seen this animation in the last class. When this particle executes simple harmonic motion, according to the equation y equal to a sine kx minus omega t or plus omega t, depending on whether the wave is advancing to the right or to the left. Is that right? Let's have a look at that one more time. You can see as the particle vibrates up and down, the wave advancing to the left will be a sine kx plus omega t, and wave advancing to the right will be y equal to a sine kx minus omega t. Okay, now that is a harmonic wave. Let's do a couple of problems. The wave yxt, you see that? Y, the displacement as a function of x and t. So the equation for a harmonic wave is actually a function of x as well as time. Yxt equal to a cos k times x plus 34t. You can see this is a cosine function. What does it tell you? A function can be sine function or a cosine function. The wave function will be a sine function if at t equal to 0 the particle is at the equilibrium position. If the particle is at the upper extreme when t equals 0, then the equation will be, there will be a phase difference of pi by 2. That will make the equation a cosine equation. So the wave yxt equal to a cos k times x plus 34t represents a traveling wave, advancing wave, where x is in meters and t is in seconds. What are the direction and the speed of the wave? There's nothing to calculate here. Just look at the general equation. If you notice, the equation, the general equation of a wave will be yxt is a cos k times x plus vt. You see, when the k is outside, this is of the form k times x minus vt or k times x plus vt. You must look at the specific form of the equation. So this tells you that this is a wave advancing to, is it to the right or left? To the left. And what is the speed of that wave? It's 34 meters per second. This is v, the speed of the wave. The sine function or cosine function only determines the initial state of the wave. In other words, where is the particle when you start looking at the clock? The wave yxt equal to a sine k times x plus vt is a wave traveling to the left with a speed v. So it doesn't matter whether you have a function given as cosine function or a sine function. So the wave yxt equal to a cos k times x plus 34t is a wave traveling to the left with a speed of 34 meters per second. So when you are given the equation of a harmonic wave, a lot of information about the wave are actually contained in the equation. Let's now look at another problem. At time t equal to 0, the shape of a wave pulse yx0 is described by this equation. This time the equation is not a sine function or a cosine function. It's simply a rational function. It is 0.2 meter cube divided by 2.5 meter squared plus x squared, where x is in meters. Plot yx0 versus x and give the general wave function yxt at any time t for a pulse that is moving in the positive x direction with a speed of 10 meters per second. And 2, the equation for a pulse that is moving in the negative yx direction with a speed of 10 meters per second. You see, if this is the general equation of a wave pulse, how would you make it appear as a wave equation that describes an advancing wave, whether it is advancing to the right or to the left? For a wave that advances to the right, what all we need to do is replace x by x minus vt. And for a wave advancing to the left, replace your x by x plus vt. Alright, first I have drawn that on my calculator. You can also try drawing this on the calculator. You can use the x scale as -10 to 10 and y scale. If you know how to look at a function, you can see what is the maximum value of y that you can get here. You see, the maximum value of y occurs when x equal to 0, and that maximum value will be 0.2 divided by 2.5. So you can actually draw a graph on your calculator by putting this on your graph window and choose the window x value -10 to 10, y value from 0 to 0.1. That's right. And you will get a pulse like this. So look at the beautiful wave pulse that is represented by this equation. And now, if this is a wave pulse advancing to the right with a speed of 10 meters per second, how will this equation be modified? What do? Replace your x by x minus vt. If this is a pulse advancing to the left with a speed of 10 meters per second, to represent that, you replace your x by x plus vt. Alright. At t equal to 0, the shape of the wave pulse we just saw. If v equal to 10 meters per second, for a wave that is traveling to the right, we replace x by x minus vt. Therefore, this is the equation for the wave pulse that is advancing to the right with a speed of 10 meters per second. And a wave that is advancing to the left with a speed of 10 meters per second, we replace x minus 10t by x plus 10t. So this is the equation for the wave that is advancing to the left. Another problem. A harmonic wave with a frequency of 60 Hz and an amplitude of 0.2 meter travels along a string to the right with a speed of 10 meters per second. Write a suitable equation for this wave. Well, you are given the speed of the wave, you are given the amplitude, you are given the frequency. Alright, what is the general equation? You can start by writing this general equation. Y equal to a sine k times x minus vt. Isn't that right? Well, where k is 2 pi by lambda, v is the wave speed, a is the amplitude, and so on. Well, can you obtain these values? What is the other form of the equation? The other form of the equation is y equal to a sine kx minus omega t. If you distribute this k, just distribute that k. Distributing the k, you get y equal to a sine kx minus kvt. And what does kv equal to? Do you remember what kv is? K is 2 pi by lambda, and v, 2 pi by lambda times v is actually 2 pi times f, that is omega. So the equation is therefore y equal to a sine kx minus omega t. So you must understand this equation and the equation I wrote earlier are the same equation. Okay, let's start this problem. We got frequency f equal to 60 Hz, amplitude A equal to 0.2 meter, and speed v equal to 10 meter per second. The general wave function for a wave traveling to the right is, alright, yxt equal to a sine k times x minus vt, which is the same as kx minus omega t. Alright, now we have v equal to f lambda. That means lambda equal to v over f. You see, we have v here, we have f, and therefore we can find lambda. Lambda equal to 10 meter per second divided by 60 per second. That is 1 over 6 of a meter. That is the wavelength. That means we can now come and find the value of k. What is k equal to? K is 2 pi divided by lambda. That will be 2 pi divided by, what is lambda? Lambda is 1 over 6. 2 pi divided by 1 over 6. The 6 will go up and multiply with 2 pi, giving you 12 pi. Hope you understand that. K equal to 2 pi divided by 1 over 6. That will be 12 pi. So we now know the value of k. We know the value of v. We can now write the equation for that harmonic wave. That will be yxt equal to 0.2 sine 12 pi times x minus 10t. Look at that again. A sine k times x minus vt. Alright? So, information about a wave can be used to write the equation of that wave, which is the same as, look at the way, distribute that 12 pi, you get, that will be 0.2 sine 12 pi x minus 120t. This now is of the form yxt equal to a sine kx minus omega t. What is omega equal to here? 120 pi. So this is of the form a sine k times x minus vt, which when you distribute, you get the form kx minus omega t. In other words, k times v is omega. Another problem. A wave function for a harmonic wave in a string is, this time I'm giving you the wave function yxt equal to, that is y as a function of x and time, is 0.001 sine 62.8 plus 314t. What form is this? This is of the form yxt is a sine kx plus omega t. That means your k is 62.8, your omega is 314, and your amplitude is 0.001. Look at the information you can pick from the wave equation. Alright, find the wavelength, frequency, and the period of the wave. All that information can be obtained from these values. What is the maximum displacement of any string segment? What do you call the maximum displacement of any string segment? It's called the amplitude. And the amplitude is right here. That is the maximum displacement. Alright. A. This wave is advancing to the left. How do I know? The plus sign indicates it is advancing to the left. B. The amplitude is 0.001 meter. That is the maximum displacement. K is 62.8 Newton per meter. That is your K. What is the 314? Is Omega is 314. Now K. Now is that Newton per meter? I know I told you not to confuse this K with the spring constant K, and I did actually. This K is the wave number, which is 2 pi divided by lambda. So there is no Newton there, it will be per meter. Is that right? The unit for K will be per meter, not Newton per meter. K equal to 2 pi divided by lambda. And the value of K is given to us. Therefore, lambda equal to 2 pi divided by K. And that is 2 pi divided by 62.8. And that is 0.1 meter. So the wavelength is 0.1 meter. How do we find the frequency? Frequency is obtained from the value of omega. Omega is given to be 314. And what is omega in terms of the frequency? Do you remember? Omega equal to 2 pi f. And its value here is 314. Therefore, what is f equal to? F is 314 divided by 2 pi. That is 50 hertz. So we found the wavelength, the frequency. What is the period? Once you know the frequency, how do you find the period? The period is the reciprocal of the frequency. Period t equal to 1 over f. That is 1 over 50 hertz. Hertz is per second, which is 0.02 second is the period. Well, of course we answered this already. The maximum displacement is the amplitude, which is 0.001 meter. So you can see, once you have the equation of a harmonic wave, all the information about that wave is contained in that equation. Only thing is, you need to recognize the form of the equation. It's very important. Another one. A harmonic wave with a frequency of 80 hertz and amplitude 0.025 meter travels along a string to the right with a speed of 12 meter per second. Write a suitable wave function for this wave. Find the maximum speed of a point on the string. Find the maximum acceleration of a point on the string. Well, do you remember the equation for maximum speed or maximum velocity? Maximum velocity of simple harmonic motion is a omega. And maximum acceleration is a omega squared. Well, let's pick the given data. The amplitude is given to be 0.025 meter. That is given. The frequency of the wave is 80 hertz. The speed of the wave is 12 meter per second. Well, what is the first thing we need to find? Write a suitable wave function for this wave, which means we need to find, we know the value of A. That means we need to find the value of K and omega. Those are the two things you need, because once you have K and omega, we can write the equation of the wave. Yxt equal to A sine Kx minus omega t. Why minus? It is moving to the right. And the speed we know. So it is either Kx minus omega t or K times x minus vt. Alright, let's find some of these values. We know that v equal to f lambda. Therefore we can find wavelength. We know the wave speed, we know the frequency, therefore wavelength lambda equal to v over f, that is 12 meter per second divided by 80 hertz. that will be 0.15 meter is your wavelength lambda. And therefore, you can now find the value of k. K equal to 2 pi divided by lambda. And that will be 2 pi divided by 0.15 meter. That is 41.9 per meter. You can see I have got the right unit here. K, the wave number, is per meter. How many waves per meter? Alright, we got the value of K. What is the other value that we need to write the equation of the wave? We actually don't need anything more because we got the value of V. If you want to now write it of the form yxt is A sine K times x minus Vt. I got the value of K, I know the value of V, I know the value of the amplitude. Therefore, the equation is yxt is A is 0.025 sine K, K is 41.9 times x minus 12t. V, the speed, is 12 meters per second. So this is the general equation for the wave that is advancing to the right with a speed of 12 meters per second. Or, if you want to write that in the form kx minus omega t, what all you need to do is distribute that 41.9. That will be yxt equal to 0.025 sine 41.9x minus 41.9 times 12 is 503t. This is the omega you have now. Okay, so we wrote the equation using the both forms. This is of the form k times x minus vt. This is kx minus omega t. And both are the same. Find the maximum speed of a particle. Now, Vmax equal to A omega. I want you to remember that. The maximum velocity is A omega. Maximum acceleration is A omega squared. So, A we know, omega we calculated. See, look at this. That's omega. Because the wave equation says this is A sine kx minus omega t. Omega is 503. Therefore, the maximum velocity is A times omega. That is 0.025 times 503. That is 12.5 meter per second. And the maximum acceleration is, what's the equation I said, the maximum acceleration? Is A omega squared. Again, we know the values of A and omega, and that gives us the maximum acceleration is 6,325 meters per second squared. That's a tremendous value of acceleration. Okay, we will now talk about a very important concept, a very important and interesting concept in wave motion, and that is interference of harmonic waves. What is the meaning of interference of harmonic wave? If two waves exist in a medium, how will the two waves together, what kind of waveform will the two waves together will produce? And that is what we will discuss here. Now, let's look at the contraption that I made some time ago using the straws. Now, suppose I produce two disturbances. Now, if I produce just one disturbance, you can see how that the energy advances. If I produce two disturbances, now watch, I'm going to produce two disturbances, 1, 2. Now, look at the vibration of each particle. That means each of these is now subjected to displacements from both disturbances. You understand that? this particle or this straw will be subjected to the disturbance produced here, also disturbance produced on the right side. Now that means energy from both disturbances will reach the same particle. And how will this particle then behave? That is the question of interference. Okay, let's try and understand this a bit more. Suppose this is one particle in a medium. Now it receives energy from one disturbance. You understand when I say disturbance? You see, to create a wave in water, for example, you drop a pebble, and that pebble falling on water creates a disturbance. It sets the particles into vibration, and that energy travels along the surface of water. Now, if this particle receives energy from one disturbance and moves from the equilibrium position to the upper extreme. Now, it receives energy, suppose, from another disturbance also. Now, the energy from the first disturbance instructs this particle to move up. Suppose the energy from the other disturbance wants this particle to move down. Then we say these two disturbances are meeting at the same place, completely out of phase. You see, when one disturbance wants this particle to move up, the other one wants it to move down. What is the phase difference between the two disturbances? The phase difference is T/2 or pi. Now, when the phase difference is pi, they are completely out of phase. Now, what will this particle do? Disturbance 1 wants this particle to move up. Disturbance 2 wants this particle to move down. What will this particle do? It will not move, it will just stay there. That means two waves meeting at a point, if they are completely out of phase, they will cancel each other. They will destroy each other. That means this particle will not vibrate. On the other hand, if the first disturbance wants this particle to move up, the second disturbance also wants this particle to move up, that means those two disturbances are in phase. That means this particle will move a lot up. So when two disturbances meet at a point in phase, their amplitudes will add up, producing a big wave. If they are completely out of phase, their amplitudes will destroy each other, producing no wave. Well, let's now see how I can explain this a little more clearly. That's a concept I want you to understand very well. If two disturbances are created in a medium at the same time, the energy of these disturbances will be propagated through the medium simultaneously. That means each particle will have these two disturbances superimposed on them. You see that? Each particle on the medium will now be subjected to both these disturbances. And that particle then will vibrate depending on whether the disturbances arrived in phase or out of phase. We would assume that the amplitude, frequency and period of the waves generated by both disturbances are the same. The displacement produced by the first wave can be written as y1 equal to a sine kx minus omega t. Suppose this is the equation for the disturbance created by the first wave. Now, a second disturbance a little later means there is a small phase difference there. And how will you represent that? We're going to represent it by that phase angle delta. Suppose a second disturbance which happened a little later. We will represent that as y2 equal to a sine kx minus omega t plus delta, where delta represents the phase difference between the two disturbances. If this delta is 0, that means there is no phase difference. They are in phase, which means you will get a bigger wave. Here, delta is the phase difference between the two waves. Since each particle in the medium will be subjected to both these displacements simultaneously, the actual displacement of a particle will be the sum of the displacement produced by this wave and this wave. In other words, the net displacement of each particle will be the sum of y1 plus y2. You see, if only the first disturbance existed, then the displacement of this particle will be given by y1. If this is the only disturbance, then the displacement will be given by y2. But this particle is now subjected to this disturbance and this disturbance. That means the displacement of this particle will now be y1 plus y2. And what will that be? The net displacement now equal to y1 plus y2. And let's write it that way. Y equal to a sine kx minus omega t plus a sine kx minus omega t plus delta. Now, does your trigonometry allow you to simplify this? Let's go to the other slide and do that. If the two waves are in phase, that means there is no phase difference, then delta will be 0. That means disturbance 1 and disturbance 2 will arrive at this particle in phase. So delta will be 0. What will therefore be the total displacement? Will be a sine kx minus omega t plus a sine kx minus omega t, which is 2a sine kx minus omega t. The displacement of this particle will be twice its normal displacement. Now, this kind of a superposition, one wave superimposing on another, so that they are in phase, is actually called a constructive interference. What's the meaning of constructive interference? Well, it adds up. Now, if two equal waves interfere in phase, the resultant wave has twice the amplitude. You see, in place of A, you have 2A. When the interference is constructive, the resultant wave has twice the amplitude. Now, look at this. One wave added to another wave, they are in phase. How do you know they are in phase? The crest of one wave falls on the crest of the other. The trough of one wave falls on the trough of the other. This is how waves superimpose in phase. That produces a bigger wave. Look at the bigger wave, a bigger amplitude. And this is called constructive interference. When two waves meet in phase, you have a constructive interference. Okay. On the other hand, if delta equal to pi, what does that mean, delta equal to pi? The phase difference is pi, means when one disturbance wants the particle to move up, the other disturbance wants it to move down. That means due to one disturbance, if the particle has to be on a crest, due to the other disturbance, it has to be on a trough. You see, the crest of one wave falls on the trough of the other wave. What will happen? The particle will not move anywhere. It will not be on the crest of one wave, nor will it be on the trough of the other. It will simply remain in the equilibrium position. So, this will be y equal to a sine kx minus omega t. plus a sine kx minus omega t plus pi. If you simplify this in trigonometry, it will become, I'm not going to take time to do that, but a sine kx minus omega t plus pi is the same as negative a sine kx minus omega t. And you can see this is a sine kx minus omega t minus a sine kx minus omega t, that's 0. The resultant amplitude when the two waves meet completely out of phase is 0. If two equal waves interfere completely out of phase, the resultant amplitude is 0 everywhere in the medium. That means there is no wave. The displacement created by one wave will be cancelled by the displacement created by the other wave. Particles in the medium will simply stay at rest. Now look at the representation here. One wave, if a particle here is supposed to be on a trough due to wave 1, it is supposed to be on the crest of wave 2. The trough of one wave falls on the crest of the other, and the crest of the first wave falls on the trough of the other. These two waves are completely out of phase. What is the phase difference between these two? It's pi. What is the result? There is no displacement. And what do you call such an interference? It is called a destructive interference. So interference can be constructive or destructive. If delta is other than 0, you see, if delta is 0, you have a constructive interference. If delta is pi, you have a destructive interference. In practice, the value of delta can be anywhere between 0 and pi. So you can have a situation in between. Then the total displacement of each particle will depend on the value of delta. So it will be therefore y equal to a sine kx minus omega t plus a sine kx minus omega t plus delta. Now in trigonometry, there is an equation that will help you to simplify this. We will use the trigonometric identity for sine A plus sine B. If you notice, A stands for this quantity, kx minus omega t, and B stands for this quantity, kx minus omega t plus delta. Now, does anybody remember that trigonometric identity for sine A plus sine B? Well, this is that identity. Sine A plus sine B is 2 cos A minus B divided by 2, or 1/2 times A minus B times sine 1/2 times A plus B. Now, what all we need to do is figure out A minus B, where A is kx minus omega t, B is kx minus omega t plus delta. Tell me, what will you get if you subtract this quantity from this? Let me write that down for you. That will be A minus B will be kx minus omega t minus kx minus omega t plus delta. That will be kx minus omega t minus kx plus omega t minus delta. And if you notice here, kx minus kx will go, negative omega t plus omega t will go. You will be left with a negative delta. So this will be 2a cos A minus B becomes delta, negative delta. So that will be cos of negative delta over 2. Alright, what is A plus B? when you add kx plus omega t plus this, what will that be? Well, that'll be 2kx minus 2 omega t plus delta over 2. Alright, I'm going to write down that for you. So this will be 2a cos. I showed you that a minus b will be negative delta. And you should also know that cos of negative delta is the same as cos of delta. You know why? Because cos is positive in the fourth quadrant. So we get, this is actually cos of negative delta over 2, which is the same as cos of delta over 2. And when you add this quantity to this and divide by 2, you get this. Kx minus omega t plus delta over 2. So this is the general form when two waves meet at a point with a phase difference of delta. Alright, now why have I colored this quantity? If you look at this, 2a cos delta by 2, here is a constant, where delta is the phase difference. Therefore, this is the amplitude of the resultant wave. The amplitude of the resultant wave is this quantity, 2a cos delta by 2. That is what I want you to take note. Alright? Now, the amplitude of the resultant wave is this, 2a cos delta by 2. When delta equal to 0, look at that. When delta equal to 0, what is cos of 0? Cos of 0 is 1. So when delta equal to 0, the two waves are in phase, then the resultant amplitude will be 2a. Cos of 0 is 1. When delta equal to pi, what is cos of pi by 2? Cos of pi by 2 is 0. Therefore, when delta equal to pi, the resultant amplitude will be 2a times 0, because cos pi by 2 is 0. That will be 0. Alright. Here I have the illustration of a wave pulse advancing from the left, another wave pulse advancing to the right, interfering at the center. Can you see that? When the wave pulse meets at the center in phase, you create a bigger wave, and they pass against each other, they interfere, and you can see the amplitude changes as we go from left to right. Each time you have the resultant amplitude. So a wave advancing from the right and a wave advancing from the left interfere, producing a larger wave at the center. Let's now do a couple of problems. Two waves having the same frequency, wavelength and amplitude are traveling in the same direction. If they differ in phase by pi by 2 and each has an amplitude of 0.05 meter, what is the amplitude of the resultant wave? Well, they differ in phase by pi by 2. What that means is, if one disturbance causes a particle to be on the crest, the other disturbance wants the particle to be at the equilibrium position. That is a phase difference of pi by 2. Now, do you remember the equation we developed for the resultant amplitude when two waves meet? Well, those equations are important. We used the trigonometry result and we said why the resultant amplitude is equal to what? 2a cos delta by 2. 2a cos delta by 2 is the amplitude. Then sine of kx minus omega t plus delta by 2. And that's a relation that we obtained. The equation of the resultant wave is given by y equal to 2a cos delta by 2 sine kx minus omega t plus delta by 2. And the amplitude of the resultant wave is this, 2a cos delta by 2. The amplitude of the resultant wave is 2a cos delta by 2. Now, the amplitude of each wave, A, is 0.05 meter, and delta, the phase difference between the two waves, is pi by 2. Therefore, when delta equal to pi by 2, what is delta by 2? Divide pi by 2 by 2, you get pi by 4. Therefore, what is the resultant amplitude? Is 2a cos pi by 4. And that will be 2a, 2 times 0.05. Anybody tell me what is the value of cos pi by 4? Don't you know that? Cos pi by 4 is square root 2 over 2. 0.707, I think. That will be 2 times a 0.05 times cos of pi by 4 is square root 2 over 2. And that gives you 0.071 meter is the resultant amplitude due to the superposition of the two waves. Okay, let's do one more problem. Two transverse waves of frequency 40 Hz propagates down a string. 2 points on the string 5 centimeters apart are out of phase by pi by 6. If this is the string, 2 points on that string that are 5 centimeters apart have a phase difference of pi by 6. What does that mean? It means a particle here has gone all the way up to the upper extreme. The particle here has just received the energy and begins to vibrate. That's the meaning. The phase difference is pi by 6. What is the wavelength of the wave? At a given point, what is the phase difference between two displacements for times 5 milliseconds apart? What is the wave velocity? Alright, let's start part A. What is the wavelength of the wave? Now, wavelength is the distance between two nearest particles that are in the same phase of vibration, isn't it? Yes. Now, a phase difference of 2 pi. You know that if the phase difference is 0, it is the same as a phase difference of 2 pi. For example, when one particle completes one vibration, a second particle begins to vibrate. They are in the same phase of vibration. You can say the phase difference is 2 pi. So a phase difference of 2 pi between two particles means that they are in the same phase of vibration. So we are looking for wavelength. Means what is the distance between two particles that have a phase difference of 2 pi. That's what we're looking for. Now here, a length of 5 centimeter corresponds to a phase difference of pi by 6. You can see this is a very simple problem that we use for normal shopping. Now, a phase difference of pi by 6 correspond to a distance of 5 centimeter. What are we looking for? We are looking for the distance between two particles that differ in phase by 2 pi. If a phase difference of pi by 6 correspond to a distance of 5 centimeter, a phase difference of 2 pi will correspond to what distance? That is what we are after. Now, what all you need to find out is how many pi by 6s are there in 2 pi. Can you tell me that? How many pi by 6s are there in 2 pi? There are 12 of them. Pi by 6 multiplied by 12 is 2 pi. That means To find the distance corresponding to a phase difference of 2 pi, what all you need to do is multiply the 5 centimeter by 12. That will be 60 centimeter, and that will be the wavelength. Here a length of 5 centimeter correspond to a phase difference of pi by 6. There you got a distance of 5 centimeter. The phase difference between these two particles is pi by 6. So delta is pi by 6. What length will correspond to a phase difference of 2 pi? That's our question. 2 pi is 12 times pi by 6. There are 12 pi by 6s in 2 pi. Therefore, the corresponding distance will be 12 times 5 centimeter, which is 60 centimeter or 0.6 meter. 0.6 meter is the distance between two particles that are in the same phase of vibration or having a phase difference of 2 pi. That means the wavelength is 0.6 meter. I hope you understood or followed the argument I am using. Now, in B part, at a given point, what is the phase difference between two displacements for times 5 milliseconds apart? Now, what is the information we know? We know that the frequency is 40 Hertz. In 1 second, the particle vibrates 40 times a second. That is the meaning the frequency is 40 Hertz. Therefore, what is the period of the wave? The period is 1 over 40 of a second, 0.025 second, which is 25 milliseconds. And you know that during the time the particle completes one vibration, the distance traveled by the wave is a wavelength. Now tell me, what is the distance traveled by this wave in 25 milliseconds? Is 0.6 meter, the wavelength. So this means that the phase difference between two displacements, so the phase difference between two displacements a wavelength apart is 2 pi. So a time of 25 milliseconds correspond to a phase difference of 2 pi. Therefore, the question is, a time of 5 milliseconds will correspond to how much phase difference? That's the question we want to answer. To cause a phase difference of 2 pi, the wave pulse travels for 25 milliseconds. Therefore, when the wave pulse travels for 5 milliseconds, the phase difference is 2 pi divided by 5, 1/5 of that 2 pi. Alright, what is the wave velocity? Wave velocity V equal to F lambda. Frequency is given to be 40 Hertz, and lambda, the wavelength, we just calculated as 0.6 meter, and therefore wave speed is V equal to 40 Hertz times 0.6 meter, that is 24 meter per second. Well, these problems are very representative problems, and harmonic waves are an important part of wave motion and particle vibration. Now, in the next lesson, we are going to see another concept, which is a harmonic stationary wave. Alright, I will see you for that lesson a little later. In the meantime, please do all your homeworks. Alright, I will see you for the next lesson later on.